Welcome to The Explainer. Today, we're tackling a massive, fundamental shift that's happening right now in enterprise tech. We're diving into Empower ID's 2026 technical architecture paper, which is titled From Authority to Effect. And look, this isn't some distant sci-fi vision of the year 2035. What we're looking at is a highly practical 24-month roadmap for how we're actually going to govern autonomous AI agents in the real world. Because if you've ever wondered how on earth you let AI execute complex tasks completely independently without just handing over the keys to your entire digital kingdom, well, you're going to want to strap in for this one.
Here is our roadmap for today. We're going to break this down into 5 parts. 1. The AI agent problem. 2. The architectural thesis. 3. The 5 core capabilities. 4. Governed execution explained. And finally, 5. Real-world agent control.
All right, let's jump right into part 1, the AI agent problem.
For decades, our security systems operated on a pretty basic assumption, right? We assume the user's login session roughly matches the length of the actual human task. Well, AI agents completely destroy those old rules. In the legacy identity and access management world, you grant access at login. It's essentially a static perimeter, but when you introduce an AI agent, an access token can easily and often does outlive the human intent that originally authorized it. Think about it. If an agent is working in the background for 3 days straight, scraping data, summarizing reports, a valid session token absolutely does not guarantee that work should still be happening. Context changes. So access has to be evaluated at the exact moment of the action, and it has to be bound by the specific mission itself rather than just some arbitrary login timer.
So, how do we fix this? That brings us to part 2, the architectural thesis.
Think about what a compiler actually does in software development. It takes high-level intent, like human-readable code, and it translates it all the way down into specific, executable machine instructions that a processor can safely run. Runtime authorization for AI has to function exactly the same way. We simply can't just give an AI general permission to do things. It doesn't work. We have to take a durable record of the approved work, check the current environmental conditions, verify the current authority, and then literally compile all of that context into a single-use execution permit for one specific, isolated action.
And this right here, this is the golden rule of this entire new security boundary. An agent may propose, but it can never, ever self-grant. An AI model might interpret a broad business goal perfectly. It might propose a brilliant series of steps to achieve it, and it could even draft the exact code required to execute those steps. But we have to fundamentally prevent a model from deciding on its own that it needs more access to finish a job. Authority has to originate from a trusted external issuer, dictated by strict organizational policy. The AI is the engine, sure, but it doesn't get to pave its own roads.
Let's look at the nuts and bolts of how this works in part 3, the 5 core capabilities.
To actually make this massive paradigm shift a reality within the next 24 months, Empower ID relies on 5 specific operational pillars. And together, these pillars replace those static, human-centric sessions with true, ironclad agent governance. Let's break down exactly how these 5 capabilities change the game for enterprise security.
Pillar number 1, work actually becomes a governed object called a mission. A mission doesn't care at all about a user's login session. It independently dictates why work may continue. It's kind of like a smart contract for enterprise tasks. It has a very specific purpose, a set financial or compute budget, hard constraints, and a strict lifecycle. If the mission is paused by an admin, or say it's automatically revoked by a policy trigger, boom, the work stops immediately. It doesn't matter if the underlying access token the agent happens to be using still has 10 hours left on it. The mission is the ultimate overriding authority.
Number 2, we need continuous signals. We literally can't afford to sit around waiting for a token to expire to change an agent's permissions. This is exactly where frameworks like SSF, the Shared Signal Framework, and KAP, the Continuous Access Evaluation Profile, come into play. These protocols push real-time evidence to inform your security policy. Let's say a user delegates a task to an agent, but then, out of nowhere, that user's device gets flagged for malware. A signal is instantly pushed, and the agent's authority is immediately narrowed or completely suspended mid-task. It's continuously evaluating trust based on real-time reality, not some login event from hours ago.
Moving on to the third capability, action time off. When a human approves an AI task, let's say something broad like reconcile these Q3 invoices, that mission is approved way before the individual API calls to your accounting software even exist. Action time auth bridges that gap. Using standards like Authzen, it mandates that we evaluate the concrete action, the specific database target, and the exact parameters at the exact millisecond the agent reaches for a tool.
This is what prevents an AI with broad permission from suddenly taking highly specific, totally unauthorized subactions.
Capability 4 is all about controlled effect. The system consumes a manifest-bound single-use permit right before dispatching the action out to the real world. Now, why do we do this? Well, so a rogue agent can't just steal the API keys and bypass your security infrastructure entirely, because if the AI holds the credentials, the AI is your perimeter, and we definitely don't want that. Under this architecture, the execution plane holds the keys, not the AI, and it only ever uses those credentials if a tightly bound permit is valid.
And finally, number 5, causal evidence. Look, if you've ever had to do a post-mortem on a security incident, you know the absolute nightmare of digging through scattered, uncorrelated system logs trying to piece together what happened. This architecture replaces that nightmare with one unbroken causal chain, joined entirely by the mission ID. You can query exactly what human intent was approved, what real-time signals informed the AI's decision, what API call was actually dispatched, and what the final outcome was. It is total cryptographic accountability for autonomous work. Okay, let's zoom in on where this all happens in Part 4, Governed Execution Explained.
Now that we have those 5 pillars down, let's trace the exact sequence of the last safe point before an agent actually alters the real world. First, the agent proposes an action based on its own logic. Next up, a canonicalizer prepares a manifest detailing exactly what that effect will mean in practice. Then the policy decision point, or PDP, reviews the context and makes a choice to approve or deny it. If it's approved, a single-use permit is consumed, and only then is the effect officially dispatched to the target system.
The takeaway from this process is absolutely massive. The agent gets the action, but it never gets the key. This fundamentally isolates your risk. If an agent goes rogue, or it hallucinates, or say it falls victim to a really sophisticated prompt injection attack, it can certainly try to propose unsafe or malicious actions. But because the system is designed this way, it can never extract the underlying reusable credentials to bypass the boundary. The execution plane mediates absolutely everything, which ensures your most sensitive access tokens never touch the AI's working memory.
Let's bring this all together in our final section, Part 5, Real-World Agent Control.
Let's ground all this heavy theory into a practical, real-world application. Imagine your enterprise deploys a highly capable AI agent to gather sensitive financial data and autonomously generate the quarterly board packet. The mission strictly bounds where that completed packet can be sent, say only to recognized board member email addresses. Every single query the agent makes to the finance database requires that action time authorization we talked about. But what if the board meeting is suddenly canceled or a member is unexpectedly removed? A revocation signal hits the execution plane instantly. And just like that, the external email dispatch is denied at the boundary, even if the agent's background processing token is still perfectly valid. Now, if you're an enterprise leader looking at all this, take a breath. You don't have to boil the ocean on day one. You can actually scale this assurance progressively across your organization. You might just start at level AA1, simply recording missions for read-only agents, so you actually have an inventory and some basic visibility. For sensitive rights, you'd step up to A3, mandating that governed execution and credential mediation. And for highly privileged irreversible effects, like modifying production databases or wiring actual funds, you lock it down at level A4, enforcing strict separation of powers. You apply the security friction only where the business risk actually demands it. So we're going to wrap up this explainer with a pretty vital question, one you really need to ask yourselves as you map out your AI identity strategy and prepare for this agentic future. If your AI agent goes rogue today, what exactly is it authorized to destroy? The shift from human authority to agent effect is happening right now, and the old tools just aren't going to cut it anymore. Implementing mission-bound, signal-informed decisions and governed execution ensures that when your agents act, they are acting strictly within your control. Thanks for joining me on The Explainer.